Hello everyone, my student number is 10454-163. Today I'm going to take a look at the UDP analysis, the connection that's particle in the whale shark. Firstly, I'm going to talk about how UDP works and what is it in the UDP header. In computer networking, the user datagram particle UDP is one of the core members of the Internet Particle Suite. The particle was designed by David P. Reed in 1980 and formally defined in RFC 768. With the UDP, computer application can send a message, in this case referred to as datagrams, to other hosts on an Internet particle network. Period communication are not required in order to set up communication channels or data paths. UDP uses a simple connectionless communication model with a minimum of particle mechanisms. UDP provides checksums for data integrity and a potent number of addressing different functions at the source and the destination of the datagram. It has no handshaking dialogics and thus explores the user's program to any unreality of the underlying network. And there is no gradient of deliver, ordering, or duplicate protection. And then we'll show the UDP in the whale shark. We will open the field I created. Here is a capture of a field of data and a maximum of application and particle. We can click one. There we can see the packet details and look at the user datagram particle. And in the UDP header, there is very few fields. UDP always has 8 bits in its header, and there is only 4 fields. There is a source port, which is 53, and the destination port, which is 4374. And the length is 52, which is the totally length of the packet, including header and data and data. And the last one is the checksums, which is barely dates the header information, but it does not encompass all of the data like that we expect with the FCS in a frame at the end of the frame. And we can see the checksum is unverified, and we can go to the edit to the references, and to the particle we can find the UDP. And we can see a variable date, the UDP checksum if possible. We click that, and then OK. And we can see the analysis is correct. If there are any problem in the header, it was manipulated and transformed. We will be able to see that here, and it will be marked then. If you expect, it will tell you what checking some information is that we will have with the UDP transform is either they work or they do not guarantee any connectivity, and the complication will perform any sort of retransmission if necessary built into the application. It's not handled within the shell like it is a TCP, because it's a very small header and very few filter. There are few options to be turned on or off. There is not much. It means to be very simple and lightweight, which is great for the voice over IP. Or streaming video, anything like that is very time sensitive. It sends the data on its way, and it hopes it gets their great. If it doesn't, then well, you miss the package. Or one thing you can do if not sure a packet is a UDP or not, when looking through the package list up top, we can create a column based on the UDP like this, and we can see all the UDP information. We can know if that belongs to the UDP. If the column is black, it means not belong to that. That's all information about UDP, and thanks for everyone.